Solving inequalities follow almost the same rules as equation solving. Let's check out an equation. 8x plus 5 equals 2x minus 13. What we need to do is put all of the x terms together on one side of the equation with all of the unattached numbers together on the other side, moving them using the laws of algebra. Here's one way that we could do that. That gives us 6x plus 5 equals negative 13. Now the 5. 6x equals negative 18. And x equals negative 3. Notice that we had an equals, an equals, an equals, and an equals, and nothing that we did changed the balance of the equation because we were subtracting the same thing from both sides and dividing the same thing on both sides. Now let's check out solving an inequality. What if this equation became an inequality? What would change? We would have to organize it so that the x terms were together and the unattached numbers were together. And now let's try a slightly different order for rearranging. First, we'll do the subtraction and end up with 8x is less than 2x minus 18. Notice that subtraction does not change the inequality any more than subtraction changed the equation up here. The reason is because we subtracted the same amount on both sides, so what was smaller is still smaller. Now we're going to subtract the 2x, and again we end up with 6x is less than negative 18, and the inequality remains the same. That's because we subtracted the same amount from both sides. Finally, division by a positive number also keeps the inequality the same as it was. The only difference between solving equations and solving inequalities is because x less than negative 3 includes very, very many numbers. We like to put the answer on the number line. Here's what it would look like. First, we want to put a 0 somewhere in the middle of the line, and then mark off negative 3 to the left. We're going to put an open circle around negative 3 to show that our inequality began with negative 3. Then we're going to shade the number line for all the numbers that are less than negative 3, but leave an open circle to show that negative 3 is not part of our solution. The rules for solving inequalities do change when you multiply or divide by a negative number. Let's see what changes here when we solve for x. Now there's a negative sign in front of the 5 attached to the x. So as we isolate the negative 5x portion of our inequality, we have to subtract the 6. That gives us negative 5x is less than negative 15. Notice that there was no change because we subtracted. The fact that negative 9 was negative, the fact that our subtraction involved using negative 6, the fact that negative 15 was the result of negative 9 combining with negative 6 doesn't change the inequality. Here it comes. When we divide by negative 5 on both sides of the equation, that's when the inequality switches from less than to greater than. And again, as we did before, we want to graph the number line to show the solution. I usually like to put in 0 because I'm a compulsive person, but as long as you put in the number 3 and you're shading to the right, it doesn't matter. So again, an open circle around the 3, shading to the right because that's where the numbers that are bigger than 3 are, and filling in the arrow to show that that's inclusive. What would happen if we changed the inequality from less than to less than or equal to? What if we put a little line over here and a little line over here, which put a little line over here, so that now our inequality was greater than or equal to? That's right. The only difference would be that we would fill in this circle to show that 3 was included in the solution set. And another neat trick that a number of you noticed was when x is on the left side of the inequality symbol faces in the exact same direction as the shading on the number line. Greater than here with the arrow here. That only works when x is on the left side of the inequality. It doesn't work when it's on the other side. I don't usually rely on that. I just speak in English, which is my favorite thing. And I say that the x's are bigger than 3, and then look at the number line and find where the big x's are and shade it in. But if you like this trick, totally use it, as long as you're careful about where x is.